Hello and welcome back to Compiler Programming. Today I want to walk through the refactoring that I did recently that enabled some of the nice functionality that we will actually gonna implement today. And what I'm talking in particular is a more generic version of this function, which is like size of. So obviously in C you also have the size of operator, right? You can put any kind of expression here, and you can do like, I don't know, foo 0, and it'll tell you that the size is 1 because we are accessing a character A and element is 1 byte. The thing about size of expression is that it doesn't actually evaluate what is inside of it, right? So we would say size of and I don't know, launch nukes, and this function will actually not going to be executed. We are just going to get the size of the result of that function. So previously, there was a coupling between trying to get the size of an expression or the type of the expression and actually evaluating it, and the refactoring I did was to remove that. So now there is a sort of an AST that is composed of the lazy functions. So there is this new lazy value type, and as you can see that this type has a descriptor. So even before outputting any code or doing even some of the processing on the code, we already know that type. And this is exactly how this size of stuff will work. And there is also type of, which will just return a descriptor to us. In fact, we could theoretically implement type of, size of in terms of type of in the userland, but I'm not sure I will get to that today. The very first thing though is to change this test because I want to actually use size of for this, and that means that in test we need to have some different name. So let's just quickly do that. We'll just change it to my size of, and that should be enough. Okay, that still works. We will commit it separately. Rename size of to my size of in a test. Okay, so that's just some setup. Now we are ready to rock. The question is, where would we put that? And well, let's just put it somewhere here, I guess. It doesn't really matter where we do that. The only thing I do want is a test that is successful. So let's copy this one and go from there. Should be able to get the type of an expression without evaluating it. And testing this is kind of interesting. So to make sure that we are not actually evaluating an expression, we'll need to have some setup. So the first thing is we will need to have a global variable. So let's say, I don't know, doesn't matter, foo or counter is 0. Then we need a function that would, well, we don't really need a function. We can use a block actually. So we'll say, how do you want to do that? We need to figure out where to use type of. I guess, and I want to use it not in a constant expression, but in a runtime expression, so that I'm not gonna accidentally not evaluate it because it wasn't a constant expression. Let's do the following. So let's do foo, and we're gonna say that the type of foo is going to be type of It's an interesting question. Do I want the type of to be one word or do I want it to be with underscore? I think I want it with underscore. So foo is a type of, and then we do the following. So we have a block, and inside the block we will say that counter is 1, and then we will return so here we also need to be careful. I guess we will say var is 0 and we return var. So the reason I didn't return a value here, like I didn't return just 0, is because the type of a literal is a separate type. So the type of literal is number literal inside of the compiler, and I still haven't decided what are the exact rules where this type is forced to be an integer type or a float type. So I try to preserve it as much as I can, and that means that in this case, if you want to force it to become a 64, then we need to do this. I mean, I also can do something like this. This is a bad expression in the sense that we now have an uninitialized value. So I think this version is sort of safer and it does the same thing. Okay. So we have foo, which type is the type of this expression. And now we are going to return a counter. Right. And when we call this function, this actually needs to be s64, s64, s64. Okay. And when we return it, we expect the counter to be 0, right? So again, inside type of call, whatever is in here, we are not supposed to be evaluating it. We are only interested in the type of this expression. So that means that this code should never run, and that means that counter should stay 0, right? Hopefully that makes sense. Now, obviously, when we try to run this test, it will fail with some spectacular error message because we don't support type of. Really. Yeah, so it says cannot resolve the type and actually is connected with something completely different, which might cause a bit of a problem here. So let's actually remove this as a part of the type, because we can also run this expression like this in meta assembly. There is sort of no difference between types and values, and types are values. That means that we can just have an expression that returns us a type, even at runtime. That's not really a problem. So this is what we're doing here. We are just trying to get a type. And then this version maybe we'll do later in the video, or maybe I'll do it off the video. We'll see. Because that has to do with parsing and not really connected to the topic at hand. Okay. So let's try to test again and see what happens. It should say we don't know what type of is. Yep, undefined variable type. That's great. That's exactly what I was thinking would happen. And now we can try to fix this. So the way we are going to fix it is that there is this function that's called mass handle parent operator, and that just handles these kind of built-in functions that are not really functions, in a sense that they operate not necessarily on the value. So like they don't force their arguments to become values. They can do some reflection stuff, and eventually I want to have a mechanism for user-defined functions that also, instead of forcing value, just accept its sort of type or internal value. but for now, these have to be here. Okay, so we have, I think storage variant of is something similar. We can also copy the cast, and that is not really important which one we go for. Let's say type of, and actually we'll say return token handle type of, and that would be context and args token this way. Great. So let's try to write that function. Right. Value star like this. We have it here. Great. Value star args token. And we need to figure out what to do about that. The whole thing should be pretty easy because we can actually reuse this token magical arguments function that will parse the arguments for us. Okay, context arg token, args range, that is not a thing, so args token source range, right, actually like this. Okay, so first thing is we need to check that if args, actually if dynamic array length of args is not 1, then we need to report an error. So let's quickly grab one that we can copy, and then we have args token source range, and we need to say that type of expects a single argument. Okay, that's a pretty decent error message. Now we can do value star expression is dynamic array get args 0. We can immediately drop the array because we already got the element and start by pointer. Okay. In fact, actually, maybe we should not do that and do instead like this. I'm not certain which version is better. In C, it's kind of awkward to work with errors regardless. So maybe we'll do this version. Okay, great. So we have our arguments, we match them, we got the expression back, and now we should be ready to actually get its type. So there are two possibilities. Either the expression is one of these lazy values, in which case we get the descriptor from here. The other possibility is that the compiler sort of does constant folding as it goes, and if it has expression that is known to be constant before evaluating, it does not create a lazy value because there is sort of no reason to. Like if the evaluating expression will not produce any assembly code anyway, then it doesn't create lazy values because those have performance cost associated with them, and it is better to just not do that. But it does complicate the usage somewhat, but not too much. So what we need to do is we need to say const descriptor star descriptor is value or lazy value descriptor of expression. And this function, value lazy value, does exactly what I was saying, where if I can find where it's actually implemented, then we would see what it does. Yeah, so here it is. So instead, it checks if the value is a lazy value, and if it is, it extracts it out of this lazy value struct. Otherwise, it gets the value of the expression itself. Okay. So we have the value, and we have the descriptor, and descriptor types are status synonymous. I still haven't decided if I want to change them to be named the same thing in the user land and in the compiler itself. I think that it gets pretty confusing inside of compiler if you call type and then you have like type and things like this, which are just awkward to talk about. So types are represented as descriptors in the compiler, but these are actually types. So we can just say that a result is going to be actually, after matching calls, we need to say mess on error, context result, and go to error. Right, we need to do that. This comma is not necessary. And then the result is value make args. What will we make of the value? We need context. And then the actual value. So descriptor type, and then we have storage static is descriptor, and then args token source range. Right. So different const qualifiers. And that is a bit awkward. So storage static apparently wants a non-const version. And this is where it gets tricky because I need to then present constant and constness inside the type. So for now, I will do the bad thing, and I will then I will add it to do consider adding const static values to avoid the cast. Okay. Right. Here there's just missing star. And potentially initialized. Yes, that's because this needs to be the first thing in the function. Okay, so that's pretty straightforward. Now we have this type of, and we have this stuff. And that should actually cause the test to succeed. At least I hope it will. And indeed it does. Now, in a test, we are only checking that we are not actually evaluating this expression, which is great, but there is a bunch of other stuff to check as well. The first one would be for the error, and so we can do that. We can check the error here, and for example, we could try to do a type of that doesn't get any arguments, right? So that's one thing that should return an error, and it should say that type of expects a single argument. That types. Right, let's try to test that. And we get expected type. All right, because that was coming from another test. We don't actually need this argument at all. Great. That looks good. So our errors are working correctly. We are not evaluating the expression. Now the only thing left is to actually try to get to use this type to get something useful out of that. There are two ways I can go about it from now. So one is I can try to get type of to be usable in these positions, but that is a larger refactoring because right now there is a separate parsing for the types and we are not expecting expressions there. So that's going to be awkward. Another way I can try to do this is set size of is should be implementable in terms of type of, but that also is very, very awkward because we don't currently have unions in properly supported in the language, and that would need to have a union. What do I want to? Which version do I want to go for? Well, I guess we can try to dive into the deep end, and we're going to implement the types. Okay, so what do that look like? I'm also trying to figure out what the test for that would look like. You know what? We will do something simpler. What we will do is we will get some field out of the descriptor, and that would tell us if this actually works. Descriptor. So what do we have? We have a name, right? Do we actually set the name in any place at all? Let's look at built-in types, maybe for that. So, right, generate type. This is where I generate these descriptors. Right. Yeah, so we actually do set the name. So that's something we can try to do then. Right. Let's take this test and should be able to get the fields of the descriptor provided from type of. Okay, so what does that test look like? Well, it will return us a string, which is called slice in the compiler, and we will do .name. Now, I have no idea what that will actually do for us, but we can try. Now, the trouble is I don't think, I'm not sure I support returning compile time strings out of the code, and this is a compile time value. So let's do, what shall we do? Well, let's try this, but I'm pretty sure it will not work. Maybe we'll start easy. We'll start with returning the length of the name. And that is U64, probably. So we should get 3. And the reason we should get 3 is because this type is S64, right? And the length of the string S64 is 3 bytes, right? So this is what should happen, but let's see if that actually does happen in reality. And it does not. Left hand side of the dot operator must be a struct. Right. So the issue in particular with the descriptor is that it is not defined to be a type. Right, yes. So there is this custom definition for descriptor. Awkward, awkward, awkward. No matter which direction I try to take this, it looks like there is very deep things that need to be changed about the compiler to actually make use of that. Okay, let's try to quickly dive into this and then think about if we need to take another approach. So this is the generated code for the types. Descriptor. Type. Size of. So what does this do? It creates an APAC descriptor and right. So why don't we, okay, we have it here. Gotcha. So what if we do it like that? Let's start with this first. Okay, that works, but that is not exactly what we want, because we want to have access to this, to the fields of the descriptor, and we want to define it as a struct. Do we even go through structs right now, or through unions? Okay, unions are defined as APAC types. Yikes. So yeah, it looks like this would be a very deep rabbit hole if we were to go in this direction. But I don't want to leave type off with just an abstract. Okay, see, this is parsed and but it's not actually used. So I guess we are in for a ride with this stuff. Right. Let me mark this and let's get back to my size of because that's how we will know it works. Mm. How do we construct a test to check that type of works? Well, let's do, I guess, the following. We will get another function, internal, whatever, that will accept S64 and it will return S64 and it will not do anything with it, but it will not actually accept S64. It will accept. Oh, I know what we can do. That's gonna be actually kind of fun. What we can do is we can do an identity function of sorts. Right. So this is not really full on generics, but we could maybe try to do this, right? So we are saying that we are returning the type of an argument. This will test even more stuff. So maybe I'm trying to do too much, but let's see. So we say x is 64 and it is 42. We want a new line here, and then we say id of x, and this is also returns as 64, and we want to get back 42. Right, let's try this. Let's generate a type so we don't have things here. Okay, so what happened was that the function failed to compile, but the error definitely could be improved. Right. We need to go to process function literal, which is a function that deals with this definition here. And we need to look at stuff. And the stuff we need to look at is return types, right? Okay, so if it's empty, then this, and if it's not, then we do token match return type. Gotcha. Well, let's try to look in and to token match return type. Identifier. Okay, yeah, we have named returns. I already forgot about that. So what we actually need to look at is a token match type. Right. So what are you doing? This seems like this needs to be first. Okay. So we try to match this fixed array type. If we fail, then we get the first thing out of the list there, and then we assume that it is a type. So this is wrong now, more or less. So this is kind of a scary change. But what we need to do is we need to say value type, or actually type, yeah, and type here is compile time eval of context and the view. Later on, I want to move a fixed array type into there as well, but for now, that's just gonna be a bit too complicated for my taste. So let's see how terribly that breaks all the other tests. And as expected, it breaks them very well. Okay, so let's find one and go from there. So this is about an error, and I don't really care about that. This is also actually fine. We will fix this in a second. Okay. This is our type of that fails. That's okay. So what is happening here? Yeah. So now we, for some reason, do not match type. Right. What do you want to do about that? I guess for now I want to hack around this. So I'll say if we'll do some duck typing. We'll get the first token and we will say if value is group token value group, no, token. I do not remember how to use this function. Okay. Okay, it's group tag, values group. Okay. Gotcha. So we say value is a group of token, and we say and value as group token tag is group tag square. So you have this type of an expression here, right? Then we do what we were doing before. Otherwise, we will do the new thing. This is kind of awkward, but I will fix this. To do fold into main parsing code. Let's see if that does the trick. Well, that's better. This test, let's fix this up because now we just changed the message, and that is okay. Right, undefined variable. Undefined variable. Okay. But that does not actually fix our problem. Our test with type of still fails. Okay, let's try to figure out what's going on. Let's open up the debugger and go from there. It's a bit too big. Yeah, doesn't fit in the screen. So, we need to have this test. Let's focus this test, and then we can go to which code we can go. Well, let's go to match type. That would be one option. And we can actually try to get to here and go from there. Well, that is not great. So we end up never going into this branch. And that is kind of strange. Okay though. Let's check here. So we never even end up with a token. Did I screw this up? I did screw this up. And the way I screwed this up is in here there should be a /n. Okay, now it should be better. Great. So we end up in here. Do we get something back? We do. We have an S64. Everything is perfect. So I think this should actually work just fine. Yeah, we're returning descriptor S64. That's perfect. So I think if I run this, it would actually work. I didn't really see that, so let's run tests from here. Apparently no. Undefined variable x. All right. So that is the side effect that we do not define x before we deal with this. Yeah, essentially we are parsing return types before we parse main arguments. So maybe if I do it the opposite way, which is more natural. Visual Studio sometimes blocks the files for no reason whatsoever to be saved, which is very annoying. So let's see if I move it around, it's gonna be better. It is not better. But now I don't trust if it actually saved. Sorry, function literal. No, it did save. Right, but we don't define the arguments in the function scope at this point in time. We do this only when we force the function to be compiled. Sure, compiled function body. It happens here, right? Body scope. And right. So this is where we define the arguments. Okay, so this is something sort of different. Again, a bit of a tangent, and I don't want to go and shave that yak. So we are instead going to do a global foo, which is ns64. Or we can do it like this. And then I would say type of foo in here and type of foo in here. And that should work because foo is a global and we should not get undefined variable. Okay. If I'm typing without underscore, maybe my brain tries to tell me that I shouldn't actually use underscore in there, but regardless of that, the test is actually passing, and here it is. That is very nice. Let us re-enable all the other tests and see if all of them are still passing as well. And they are. This is great. So let's which episode are can I do? I don't probably have grep. Do I have grep? Oh, I have RG, I think. Episode. Great. So we are. I don't know where episode 156 went, but we are at 158. Okay, so let's commit this. Git commit. And we would say episode 158 implement type of support. This is pretty cool. Now we can put types, put expressions in place of types, which brings a macro programming at the next level, which is very, very nice. And the last one that I wanted to do today is size of. That should be pretty easy. I will not do in-depth checks on this, and because later on, as I said, I will want to move it into the userland. But for now, we say should support size of, or maybe we have it the same thing here. Say size of an expression without evaluating it. But as far as size of goes, we can return it directly, right? And there is a good question: what should it return? I think it should return a number literal, but it will be converted to a 64 just fine. So let's well, this test actually should stay like this, but we should also create a one that just returns as the size of. And it will be like this, like this, like this. Remove the counter. Var is 0. Right. And we say size of var. That looks pretty good. And we should get back 8 because the size of this should be S64, which is 8 bytes. Right? That seems pretty good. And all that's left is to actually implement this. It is very similar to type of. Again, I might use type of previously to implement this, but for now, let's just do it like this. Right, we get the descriptor, but we do something different. answer get a descriptor, what we do is we say u64 byte size is descriptor byte size of descriptor, and we say that result is I don't remember that function. It's like value number literal. Yeah, that seems what we want, except that this parses it from the digits and I want to do it manually. So let's do just that. We create a number literal object. We say that bits is, well, that's gonna be byte size. We don't need OK. We just put base is 10, negative is false, and bits is byte size. Okay. So we have literal, and we will say storage literal here. This will be descriptor number literal. That to do is not important for this thing. And that's about that, I think. Context allocator. And here we're just gonna add another one. I will just say size of and size of. Right? Let's try to run the tests and see what's gonna happen. Great, that is first try. We have this side of here, we get the right thing, we can verify that the test is not failing just by itself by trying to Visual Studio. I don't want to close. Okay. So now this should fail. Yep, they failed it, and we put it back to 8, and we have success. So this is pretty cool. This was a functionality that I was missing for a long time, especially size of, like you use it all the time, at least in C. You would expect that I would use type of quite a bit in the math language as well, because this is something available. It's actually also available in GCC to a degree. So there is a GCC extension that allows you to actually do this in C, which is very handy for writing macros. But now we have that, and that is nice. So that is all I wanted to do today. If you stayed this far, then thank you very much for watching, and hopefully see you next time.